Don't let its frozen exterior fool you. The dwarf planet Ceres might have once been a warm, life-sustaining world, fundamentally reshaping our understanding of where life could have taken root in our solar system. A billion or so years after its formation, this icy celestial body may have possessed the exact conditions necessary to support life, suggesting that habitable environments could be far more common than we ever imagined. But here's where it gets controversial. Could life have actually begun on this tiny, overlooked world right next door? At first glance, Ceres appears to be a cold and geologically inactive dwarf planet. However, groundbreaking research now indicates that during a specific window in its ancient past, roughly between 500 million and 2 billion years old, its interior could have been warm enough to create a habitable environment. Sam Corville from Arizona State University, a key researcher on the study, is cautious about making grand claims, stating he cannot confirm if life ever did arise there. However, he emphasizes that if it had, the environment on Ceres at that time would have been perfectly capable of allowing that life to not just exist, but to potentially thrive. We've known for a while that Ceres holds clues that point toward habitability. Previous missions have detected signs of water ice and even organic molecules on its surface, two of the fundamental building blocks for life as we know it. But this new study took a different approach. Instead of just looking for the ingredients, the researchers asked a more profound question. What would any potential alien life forms have eaten to survive? And this is the part most people miss. They shifted the focus from what life needs to exist to how it would actually sustain itself. To find an answer, the team looked to Earth's most extreme environments for inspiration. They considered microbes like those found in our planet's deep-sea hydrothermal vents. These incredible organisms don't rely on sunlight or consuming other creatures. They are chemosynthetic, meaning they extract energy directly from chemical reactions in the mineral-rich fluids spewing from the vents. The central question became, could similar, hardy microbes have survived by feeding on chemical energy within a hypothetical ocean on a young Ceres? The researchers used sophisticated computer modeling to simulate Ceres' distant past. Their models revealed a fascinating possibility. When the dwarf planet was younger, heat from its core could have driven a process where warm, nutrient-rich fluids from deep within its interior percolated upward. These fluids would have mixed with the colder water in its subsurface ocean, creating a continuous delivery system of chemical food, a potential feast for any microbial life that might have been present. This idea has massive implications. Amanda Hendricks from the Planetary Science Institute points out that if our goal is to find evidence of life, either past or present, we absolutely must turn our attention to ocean worlds like Ceres. The real shocker, however, is that this life support mechanism isn't unique. The study suggests that the same process could have easily occurred on countless other Ceres-sized icy moons and dwarf planets scattered throughout our solar system. It may mean that the number of worlds that were, or even still are, habitable is vastly greater than our previous estimates. This leads to a thought-provoking and somewhat controversial interpretation from the research team. Joe O'Rourke, also at Arizona State University, boldly states, if Ceres was habitable in the past, then probably there are tens of asteroids and moons that were also habitable in the past. And if you can keep them hot, maybe they are still habitable today. Sam Corville takes this idea even further, proposing that habitability might not be a rare freak occurrence, but rather a natural consequence of putting the right ingredients together, which seem to be the common ingredients in the solar system. Of course, many details are still missing. The researchers themselves admit their model needs refinement and that a precise chemical analysis of minerals on Ceres' surface, some potentially brought up by ancient underground flows, would be invaluable. But here's the frustrating part. No spacecraft has ever landed on Ceres to collect these crucial samples, leading this tantalizing hypothesis just out of reach for now. So, what do you think? Does this evidence convince you that small, icy worlds are the prime candidates for finding extraterrestrial life? Or is it still too speculative? Is our solar system quietly teeming with countless habitable environments we've simply overlooked? Share your thoughts and disagreements in the comments below. We want to hear your perspective on this cosmic controversy.